So I'm finally back. I know I've been away for a year and a half on the AngelSix YouTube. I've gained a few kilograms and I've got a few years older. But ultimately, I'm back now and I'm going to be doing some YouTube videos for AngelSix as well. For those of you that don't know, I set up a retro gaming company that absolutely exploded a few years ago. It's only 2 years old now, but within the first year it went from a casual little project to an overnight business. We now have 4 physical storefronts, 3 online stores, and many members of staff that are now dedicated and hardworking in the retro scene, as well as myself. And I love what I'm doing. I'm building Game Boys, making new hardware, and I've been trying to figure out over the last few years how to integrate this back into what I do naturally. So for the RetroSix viewers that don't realise, I am actually a software developer by trade, and I've been doing software since I was 10 years old. I've done everything you can imagine, including games, server apps, web apps, phone apps, patented security for the NSA, encryption, you name it, all kinds of software. That's what I naturally do. That's where I make my money. The retro side has always been the fun side that I've done as something I want to do, something I enjoy. But I thought it was time to reintroduce some of my software videos. And before I started retro, I had a YouTube channel with over 50,000 subs where I taught software. I now teach hardware in the RetroSix channel, but I also want to start giving back in the AngelSix channel. So this video will be the first one that's split over both to introduce each channel to each other and introduce my retro fans to my software guys and my software guys to my retro scene. This first one, I'm going to do something nice and simple that caters for both sides of the channels. We're going to play with making some Game Boy game. No idea what we're going to do right now. We're just going to get set up, install the tools, mess around with the Game Boy development kit, and see where we go from there. Going forward, if we make software related to more than likely retro gaming, I will place it on my AngelSix YouTube, so make sure to subscribe there. And if I make hardware that's suitable for playing those games, for example, like making the flashcards open source, then that will be on my RetroSix channel. So make sure to follow both if you're interested in either software or retro, and I'll try and keep posting videos on both channels given the time. For all the old AngelSix fans, I hope you enjoy seeing me back on the scene, and I'd love to hear your feedback on what you think of at least reintroducing software. It might not be on what I was teaching originally, but we might get there. For all the AngelSix fans, definitely let me know what you feel about the new format. I know this is retro gaming, but it's still software development, and I will still do other software videos given the time, but I feel you'll still learn from this and be interested in it. So I'd like to know how many of you are actually also retro gamers or potentially interested in this avenue. So without further ado, let's just jump into the first new video on AngelSix in over 2 years. And let's make something on the Game Boy. Let's see what we do. So the first thing we want to do when we're making Game Boy games is we need a way to compile the old code. Luckily, there's a very active project. You can see days ago this project still worked on. GBDK 2020. So that stands for Game Boy Development Kit. It's cross-platform, so I'm currently running on a Mac, and I will make sure the code and the tools work for Windows as well. So your first step is to just go to GitHub and search for GBDK-2020. I'll leave links in the video so everybody can find them easy. Click to download Windows or Mac or Linux. I'm going to click the Mac. Once we have that, we can also visit the documentation link, which is here, which gives us some good information about developing for the Game Boy. We'll come back to that. We're just going to dive in and get things working. The IDE, the integrated development environment we're going to be using, is Visual Studio Code. So again, just search for Visual Studio Code, download it for your platform. I've already got this installed, so that step's done. You simply download the file and install it. Finally, the only other thing we'll need for now is an emulator to run the Game Boy games and debug them. For that, we're going to use AngelSix. It is, again, because it's a cross-platform emulator, it also has a lot of good debugging tools built in. So again, we're going to download it for our system. This is a single download file which contains everything we need for both platforms. So if we then go to the downloads and extract them both, you can see here we have the development kit for Mac. I'm also just going to quickly download the Windows one so that I can make a cross-platform solution. We'll extract the Mac version and we'll rename it to -Mac at the end. And we'll extract the Windows one and like that, rename it to Win. Clear up the downloaded zip files. And you can see this AngelSix, even though it mentions it's for AngelSix here and then with Java for Windows. I think this just simply includes Java. So if you're running on Windows, you might want to download this one. Instead, my preferred option would simply be to install Java on Windows, so you're not reliant on it within this folder. And then what I'm going to do is start a new structure. So we have RetroSix resources. This is an open source GitHub repository. Again, I'll put links in the video. We already have Game Boy Advance, Game Boy Color, Game Gear, and it contains things like board scans. So I'm going to set up a new folder. Even though this is organized into consoles, I'm just going to make a new folder called Game Development. In there, we're going to make a new one called just GB for Game Boy. And now let's make a new folder called Resources. Inside Resources, we need all three of these folders. And now we have all the tools we need to start creating code. So let's go up one folder. So we're in the GB folder. Make another folder here, and let's call it Examples. In the Examples folder, I'll make a new folder. And I think for the first thing, what we'll try and do is just get a game up and running and have it say read all the buttons and display them with text on the screen. So at least it's something useful. It could be used as a test cartridge that your buttons are working, and it gets us introduced to the whole environment that we need to build Game Boy games. So we'll just call this one 01 read buttons. And here we want to open this in Visual Studio Code. So you can either just drag and drop this to the Visual Studio Code icon. In Windows, you could just right click and select Open with VS Code. Or if we just open Visual Studio Code, we can go to File, Open Folder, browse to the newly created folder called Read Buttons and click Open. We'll trust this location. And now we have a blank project. So let's just right click in this folder and click New File. And we'll make a new C file just called main.c. I'll make this nice and big so you can see it on your screen easy. Now this isn't C#, this is C++. So if you're not familiar with C++, there are millions of guides online. And as usual, if you want to see me do any guides on C++, just let me know and I'm sure I can whip up some courses. For now, I'll just talk you through what we need. So we first need to include the code that's in the compiler for the Game Boy. So that specifically is in the GBDK that we downloaded that has header files. So if we take a look in the resources and GDPK Mac in this case, if we look in the include folder and then for Game Boy, we have headers here. So we need the Game Boy header to start with. So in order to do that, we do #include, open angle bracket, GB, press escape so it doesn't autocomplete, /gb.h for header. We'll just save this file because it will need to know where the file's located in order to fix this first error, which as you can see, it doesn't know where to find the GB header file. To fix that, just click once here, hover over the light bulb, edit include path settings. This will pop up a little helper. And all that's done is made a C++ properties JSON file. And you can see defaulted to making us this file. Now, because I want this to work on Windows and Mac, I'll leave the Mac one in there. You can see this is the file we want to add to, this include path. Everything else we don't care about. We can leave them as defaults and let them repopulate from your system settings. The only thing we want to do is add an extra folder here. So this is the workspace folder, so this folder we're in where main.c is, which if we look here is this folder here. We want to get into resources, GDPK, Mac, and include folder. So if we look at where that is relative to here, this is the workspace folder. This just simply means to include everything. So we want to go up one folder to here, up another folder to here, and then into resources, GDPK, Mac, and include. So we can leave this in, copy the extra line, and then we want to go up a folder with 2 dots, up another folder with 2 dots, into the resources folder, into Game Boy Development Kit -Mac, into include, and then include all the files inside that folder. Now you can see this is set up for Mac. If you were on Windows, you could have it auto create the Windows side for you, but instead I'll just create it manually. So this for Windows is Win32. We'll then do include path for Windows specifically, And we can then just copy these. You can now change the Mac to the Win, which is related to our Win folder, and everything else stays the same. So this first file will basically allow IntelliSense to find out where this file is, where the Game Boy header files are. Another file we'll need, because we're going to do printing of text to the screen, is standard in-out, so stdio.header. Now let's write the code that does something. So as with most code similar to C#, we have a main entry point. So we have void main, which means main returns nothing, and this is the main code loop. Let's just get something up and running on the screen to test it. So let's just do printf, which is the inbuilt standard IO here, which the Game Boy compiler recognizes and gives you this natural support to just say hello world. And we don't have to do anything else there. So the next step is we need to compile this into a Game Boy ROM that we can play on a Game Boy. So if we just jump back to the documentation, head over to, I believe it's GBDK toolchain and compiling programs, we'll find out that in order to compile, we need to call LCC, which is the compiler that is in, say for example here, in binary, and it's this LCC file here. We do an output tag to say the output name, give it the name of the ROM file we want to call, and we simply pass it in the source code, which will be our main.c file. So there's not much more to do there. The only thing we'll do as well is add a debug flag, which it now supports, which you simply add -debug, and we get some output so we can debug the code better. So we could just simply go to this folder and start a new command or terminal here, and just run LCC by referencing it relative to here and passing those arguments in. However, because we're using Visual Studio Code, so we want to be able to do Control Shift and B or Command Shift and B and run a build task. In this case, you can see we don't have any build task yet. So all we want to do is run that LCC command when we press Shift Command and B or Shift Control and B. To do that again, we'll just do in .vs code folder, right click, make a new file, call it tasks.json, and this is an inbuilt support inside of Visual Studio Code that supports running a build task. So for that, we'll just open curly braces, we'll just make the version default 2, and you can see the IntelliSense completes this for us. We'll make a new tasks, and again it completes it as an array for us. We'll give this one a label and press tab, and you can see it's pre-filled it out for us. So we'll call this one build ROM. Shell by default will run the shell on each system, and the command is the command we want to run. So this is where we could place, say directly, LCC output and do the command here. However, what we want to do is split this up between Mac and Windows first, so that we know which one we're running on. So for that, we'll simply do Windows, and then inside of here, we can do command, just like we're doing here. And then we'll do one for Mac, which is OSX. And inside of here, we'll run a certain command here. So we've just basically then made a command that will run specifics based on whether we're on Windows or Mac. And then because Windows and Mac will use different commands to determine when errors come out of these commands, so Mac will use terminal and Windows will use PowerShell by default, we want to basically pass into problem matchers these two special commands, which is for Windows it's mscompile and for Linux and Mac it's gcc. So this kind of is used to scan the output of these commands and realize when there's been an error or not in order to report it back. So now onto the command. So they're going to be basically the same command. They are going to be firstly running the LCC, but because we are in this folder, we need to go up 2 folders again, into resources, into the GBDK specifically for each platform, into bin, and then LCC. So for OSX or Mac, it would be up 1 folder, up another folder, into resources, into Game Boy Development Kit -Mac, into the binary file, and then LCC. From that, we can now do what the documentation recommends, which is to specify the output name. And if we just do, say, game.gb, and then the final one is specifying the input code, which is main.c. For quickness, I'll just copy and paste that and rename that back to Windows. And then for Windows, it needs backslashes, not forward slashes. So we'll do double because a backslash will escape a special character. And then simply change Mac to Win. So it runs the Windows specific implementation. And that should be all we need. Now, if we press Command Shift and B, you can see there's no build task found. So if you click Configure, you can open Tasks file, and it gives you all these options. And instead of doing that, in order to detect the default build script, we can simply add a group here. And you can see there we have an option build. And as well as specifying that it's in the build, however, we want to do kind build and is default to true. Now when we do Shift Command and B, you can see it's detected and executed this command on Mac. You can also see we now have a game.gb file. So we have a compiled code now. So the next question is, how do we run this? How do we see it? Well, the answer is we simply go to the resources folder, AngelSix, which we downloaded. If you're on Windows, you can run the exe. If you're on Mac or Linux, just run the jar file with Java. So just make sure you have Java installed. If it doesn't want to open with double click, just simply right click, open with, and select Java Launcher. You can see you might have to do this the first time, depending on where you downloaded it, in order to allow it to download. Click OK to the default options, and then here's the emulator. I like to do options, graphics, about 4x scale, and then from this we could go to the examples, the read, and you can see here we have the game. Drag and drop the game on, and there we can see we have Hello World printed out. Now that's all good, however, it's going to be a pain if we have to drag and drop and do all this every time we want to test. So in order to open automatically, and by just simply do run start debugging, if you just go to extensions, and in here you can type AngelSix, you'll see there's an AngelSix debugger. If you click to install that, it will install this debugger into Visual Studio Code. Actually, one other thing we need to do is go to the AngelSix and start it up, go to Tools, Remote Debugging, and click this Enabled. This then puts a check mark in and enables it. Then from Visual Studio, you can do Control Shift and P, or Command Shift and P, or you can do View Command Palette. This pops up. Top result is AngelSix attached to AngelSix. If we click that, you can see it then pops up and asks us to create a launch file. Now, in order to have AngelSix running by default when we debug, you can go Run Start Debugger, and it will pop up this option. However, you can't see AngelSix here. So instead, you go to the Run and Debug and the side menu, Show All Automatic Debug Configurations, and you can see now you can see AngelSix Debugger, and launch in AngelSix. When we click that, it attempts to launch our game in the AngelSix debugger and complains that there's no permission. Now this is also trying to open a C file, so it's not currently doing it correctly. But the key we wanted to do is to get it into this menu here. So we can now click the drop down, add configuration, and then from here, I'm just going to add a configuration to launch the AngelSix debugger. For that, we start typing type, drop down, and it says AngelSix launch. If you press enter there, you can see it pre-fills all of the window with everything we need. So this will run the AngelSix debugger. It will select launch. It will ask us for the program name, and then it will stop on entry, which means the debugger will break when it starts. So with that alone, we should just be able to press F5. And you can see now it's asking for a ROM file, which if we remember and go into our project, it's simply called game.gb. So if we were to type game.gb and press enter, now you can see it's broken into the debugger. We can click play, and it pops up here, and it's automatically loaded and run our ROM. If we click stop or we close this window, it will also stop the debugger. So now with this setting, we can just press F5 to run the debugger. But let's just improve this slightly. We can just remove this ask for program name and change it to game.gb directly. If we press F5 now, it will simply start up, load, and start the game without having to type the game name. Let's just temporarily disable this stop on entry so that we can simply now just press F5 and have the game spin up. When we need debugging or stopping, we can just use breakpoints. Now, one final thing is, say we change it to Hello World 2 and press F5. It's not going to run the latest code. So to fix that, we want the launcher to run the task build ROM. Now, because this is set to default, it's quite simple. We just add an extra step in here, and we call it pre-launch task. We open the parentheses, $, then open squiggly brackets, and just type default build task. You'd normally get IntelliSense there, it didn't pop up this time. But now, if we simply press F5, you can see down here it starts building the code and then runs the new code automatically. So if we change this to 3, we don't save the file, we don't press Command Shift and B or Control Shift and B, we simply press F5, it will save the file, build the code, and run it. So now we have a really quick and easy way to develop and just press F5 like you used to in Visual Studio to get the latest code, run it automatically, and see the debugger. From here, we can do Tools Debugger to see lots of info, Tools Memory Editor to see all the hex code, and there's a lot of debugging we can do within Emulicious. For now, we're not bothered about that, and we just want to develop our first game, which is going to read all the console's buttons and display them in text. One thing you'll notice, however, though, is we don't have debug output here yet, because we didn't add it in the command. So let's just now add, as well as the output, before the output, just do -debug in both commands. If we build again now, this will generate the debug outputs that we need in order to debug our code. You can see it's now added this CD, which is the main one, a map file, and an NOI file. You can also see now that our temporary build code and our source code are mixed, which is not good. So let's delete all of those temporary build files. What instead we want to do is when we compile, we really want to compile it into a build folder. So we just go back to the tasks again, the build task, and let's change the output folder to, say, a build folder, build game. And then the same here, build/game. Now, LCC won't automatically create the folder for us. So for Windows, in order to do that, we just do mkdir, mkr build, and then just a single ampersand to run this command afterwards either way. Because if the build directory exists already, this will fail. And if we do 2 ands, it would only run the second command if this one succeeded. But failing to create the folder because it exists, we don't care about, and we still want to run the second command. For Mac, it's basically the same command. However, for Mac, we just do a semicolon to run the second command. If we now do Command Shift and B or Control Shift and B, you can see it now outputs the game into a build folder. So it's much cleaner and easier to sort of just delete this folder and also exclude it from your Git repository when we commit to Git. We will have to update our launch JSON file as well, because we currently look for the game.gb in the work folder. Now it's inside of build, we just need to make sure to do build/game. And then let's check that still works with F5. And there we go. It still builds and runs. Let's just double check by changing this back to just hello world. And there we have it. Now, one last thing to make the tasks build on Windows, because by default Windows will use PowerShell, and this is a command batch file type of code, which is what I prefer to use. We need to tell Visual Studio Code to use command line, not PowerShell by default. To do that, just right click on the VS Code folder, make a new file, call it settings.json, so we can replace some of the default settings. I'm not going to bore you with this code, I'm just going to show you what it is. You can get this by just simply Googling for Visual Studio Code Terminal Integrated Profiles. We basically create 3 profiles here.
one for PowerShell, one for command prompt, and one for git bash, just so they're in there. This is kind of the default code that Microsoft show you. And this just obviously looks in the Windows folder, the System32 folder, and finds the command exe. So all this is just boilerplate code that Microsoft have given us. And then the final trick is to set the default profile in Windows to use command prompt. So all this setting does is override the settings in Visual Studio Code that when we press Ctrl-Shift and B in Windows, this command will use command line and not PowerShell. So that's all that file's doing there. So now we have an environment finally working, where it's all set up, all clean, and all we have to do is press F5 to launch the code. We can focus on the game. Whenever we want to make a new game now, we can simply copy this VS Code folder into our new folder and make a new main. And we can just open it in Visual Studio Code and press F5. So it's a great template to start with. So that's all the boring stuff out of the way. Let's finally jump into actually reading something and figuring out when we press buttons on the console. So let's just update this text to tell the user what to do. So press any button. Let's just create a permanent while loop, which will run infinitely while the game's running. And in order to read the buttons from the console, it's really easy. Thanks to all this Game Boy development kit, all we have to do is type joypad, open and close parentheses, and this is a method that will return, as we see, an unsigned integer of 8 bits. This is basically an 8-bit value that contains all of the buttons in a masked integer, which means it's a binary file, say for example, with 8 zeros, and the first bit will be, say, the left button, then the up button, then the down button, the left button, the A button, the B button, the start button, and the select button. And that's basically all it does. We can store this value, so let's just jump up here, make an unsigned int 8t, and let's call this buttons. Every loop we're going to update the value of buttons, and effectively read the gamepad buttons every loop. Now the joypad returns an 8-bit value, so unsigned integer of 8 bits. So there's 8 bits in there, like this. Now whenever we press a button on the Game Boy, there are actually 8 buttons. So there's up, down, left, right, A, B, start, and select. Now there's also helper constants in here. If we type J underscore, you can see the button A is 10 in hexadecimal, which is the 5th bit. So that means if we pressed A, the 5th bit of the returned value would turn to 1 when A is pressed. If we looked at B, you can see it's 20, which is the 6th bit, so B is here. So if A and B were pressed, we'd get a value like this. If just A was pressed, we'd get this. You get the idea. What that means is that this returned value buttons contains all the information about every button. So in order to display that now, we can simply do if mButtons and then a bitwise and mask against which button we want to check. So if we want to check if A is pressed, we simply do an AND, which is the 5th bit, which means this JA is basically this value, and buttons, let's presume we've got A pressed, would be exactly the same. If we bitwise ANDed them together, this would be true. However, if we press B as well, this would still be true, but if A wasn't pressed, then it would be false. So this is just basic bitwise operators. So if we say whenever A is pressed, we print out the letter A. Press F5 to run this, and let's check if it works. So you can see whenever I press A, it spams loads of A's out really fast because there's no delay. So what we want to do is simply, after every loop, let's firstly do a new line instead of it going across. And secondly, let's just wait until the buttons change. So if we hold A down and nothing's changing, it won't loop again and won't check. So that's a nice easy while loop. Just check if the buttons that we've already read currently equal the results of the live buttons that are pressed right now. So we effectively reread the buttons, and if they still equal what we read above and they haven't changed, just put a semicolon in. That's now a permanent while loop that will hang here until we change buttons. It's not efficient, but that's not the purpose at the moment. It's just to test the button presses. Press F5 again. Let's see if this works. So we press A and hold it. you can see it still says A. I have to let go, press A again, and it repeats. Now you can see it prints a blank space because the new line happens regardless if any buttons are pressed. But that's okay just for this quick example. We can add all the buttons together now by simply copying and pasting this line a few times. Changing the A for B. Change the output. Do up. Down. Left. Right. Start. Which will do a little plus. And select will do a little minus. Press F5 on that. Let's stop the emulator and press F5 again. And now you can see when we're pressing different buttons, even if we press them all together. So I'll press left now and let go, it does left. If I keep left held and press right as well, it then shows both pressed. I'll press up at the same time, down at the same time, A and B at the same time. And I can't really get all buttons to match, but you get the idea that all of them are showing up and kind of showing you what buttons you're pressing. If you're wondering what buttons to press in the emulator, just do Options, Configure Input, and then you can see Game Boy and in brackets Color, which is the same for both. And here's where the buttons are assigned. So S and A are A and B, Enter and Shift are Start and Select, and then the arrow keys are the arrow keys. So hopefully that gives you an idea of how simple Game Boy development is, and how quick and easy it is to do, as well as how fun it's going to be. So we haven't really dived into too much about where all this code comes from, how the Game Boy works, but all that will come. I think it's best on the Game Boy side of things to simply write the code and see it happening and enjoy yourself while you're doing it. And then we can dig deeper into the code as we need to. So you don't need to worry too much about how all this is directly happening under the scenes and how the screen's turned on and how the text is writing. Because in the next video, what we're going to do is a cool little thing where we're going to take, say, a logo for somebody and display it as a little logo on the Game Boy. This is cool in my business where we do retro mods, so RetroSix, because people love to heavily mod the consoles and then have their little game show up on screen. So we can flash this to a real cartridge and have this game running on a real console. So you imagine if we put our RetroSix logo into this window and then put it in a real console and turned it on. For social media and for coolness, it's good to have your logo displayed in the game. So I think next what we'll do is make a little logo display code. And then probably after that, because what we do when we build consoles is we want to quality control them. We want to check that all the buttons are working. So instead of just a boring logo, we'll probably build in some games into the system as well, so that we can have this kind of test, but a bit better visual, kind of probably showing the actual buttons pressing. Some audio, so you can hear when you're pressing stuff. And we'll probably integrate a few games, or maybe a drawing app, so you can draw on the screen and check diagonal presses, which is a common thing that you want to check when you're pressing, 2 arrows at the same time. You want to check you get a diagonal movement. So as well as just a logo, we'll make a kind of a test app first. And then from that, we'll go into proper game development and make some cool games. So I hope this first introduction into Game Boy development was interesting. As always, let me know what you think. And going forward, the software development side will be posted on AngelSix's YouTube only, and the hardware development, when we get this onto, say, real carts, will be on RetroSix's YouTube. So make sure to follow both, and depending on where your interests lie, you might be interested in one channel more than the other, but I'd definitely recommend subscribing to both. That's it for this one, and I'll catch you in the next.